Hello and welcome to Chapter 7, the human population. This is a really interesting unit or chapter, and I hope you enjoy it. I'm going to kind of run through it quickly. If you had human geography, AP human geography, this is a piece of cake for you, it should be. Okay, so human population, very, very, very low until we hit basically in the Industrial Revolution. And at that point, it basically skyrockets. And we are currently in an exponential growth curve. We hit 7 billion in 2010. I would say we could easily hit 8 billion in the next couple of years, which is kind of scary. But when you have 7 billion people on our planet having some babies, you're going to hit 8 pretty darn quickly. So the question is, does the human population have a carrying capacity? Well, a carrying capacity means there has to be a limit. Something has to be limited. For a long time, we thought it was food. We would hit a limit with food, and actually, as you see when we cover agriculture in a few months, you'll see that, yeah, we're not really limited on food. We can make a lot of food, and we come up with ways to advance our food. So is there something that is going to limit our population? Have to admit now we're starting to think water. Water is a very big concern, and we need a lot of it, and yet it might be the one. We're going to see. We'll have to wait and kind of see. Hopefully, it would be nice if our population would kind of plateau, just because we get smart enough to kind of bring it down and plateau it before we hit a carrying capacity, because you're going to see some very interesting activity if we ever do. Okay, so talking about food. We used to think it was food, but now we have great ways of making food, GMOs and stuff that have really upped our production. And now we don't really have a problem with food. Again, who knows what it's going to be, and excuse me. But I'd say there's a chance it could be water. We'll see. Maybe you guys can tell me what you guys think. Okay, so we're going to basically do demography. The study of human populations. We're going to talk about changes in population size and how that occurs, what about fertility, life expectancy, age structures, and migration, and the demographic transition model. So how do population sizes change? There's a lot of population math, and we'll practice some population math on Thursday. Births and immigration. If you immigrate, that means you're coming into a country. And of course, immigration and emigration only count when you're talking about countries. At this point, we can't immigrate or emigrate off the planet, as far as we know. Little aliens walking around out there or something. So this only occurs if you're talking about countries. If you're talking about the world, then we only have to worry about births and deaths. But if you're talking about a country's population, then you have to take immigration and emigration into consideration. So we add people through births and immigration. We subtract people through deaths and emigration. Emigration means you're leaving the country. If I decide to go off to Australia, I'm immigrating into Australia, but I'm emigrating out of the United States. So I'm going to be subtracted. So crude. Anytime you hear crude in this, crude birth rate, crude death rate, that's the number of births or deaths per 1,000 individuals in the population. So if you have 200,000 people in your population, and it says your crude birth rate is 2, well, then you added 400 people, because you had 200,000. So there's 200,000. And then I have 2 babies for every 1,000, so I'm going to have 400 babies a year. So be very careful when you see crude. That's what it means. It means per 1,000. If you are given the crude birth rate and crude death rate of the planet, you can figure out what the population growth rate is. It's crude birth rate minus crude death rate, so the difference between the two, divided by 10. And really, it's divided by 1,000, but then times 100 to make it a percent, because this is a percent. So if we take, divide by 1,000 and times 100, if we simplify that, then you're just dividing by 10. So either way, whatever you need to do to remember that, there you go. A national population growth rate for a country is going to be crude birth rate plus your immigration minus your crude death rate and your emigration. So you're subtracting those two, adding the others, subtracting them, and again divided by 10, because in this case they're crude, so they're per 1,000. Okay. Lastly, and we will practice these in time, doubling time. How long does it take a population to double? Well, there's this very complicated natural log formula that comes out to be about 69 point blah, 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 blah. It's really close to 70. So what we found for us, for our estimation, and it is an estimation, we don't know, if your growth rate stays positive and the same for a length of time, if you take 70 and divide it by your growth rate, and in this case, the growth rate we're dividing by is the percent. This is the only time, you're not supposed to do anything with percent, right? You're supposed to change it to the decimal. That is not true here. You use the percent. So if I have a population that is growing by 2%, then 70 divided by 2 is 35. So it's going to double every 35 years. So if it's at 100,000, in 35 years, it'll be 200,000. And in another 35 years, it'll be 400,000. It doubles each time. Okay, so 1 goes to 2, 2 goes to 4, 4 goes to 8, 8 goes to 16, 16 to 32. That's doubling each time. That's growth rate. Practice this. You'll get good numbers, things that divide into 70 pretty easily. 2%, 1%, 7%, 5%, 2.5%. 1.75%, just keep dividing, take 3, or take like 5 and keep dividing it down, or 7 and keep dividing it down, and by 2 and 2 and 2 and 2 kind of thing, and you will get all the numbers that they could potentially give you, but they will all go into 70 quite easily. Okay, fertility. Fertility is babies. Let's talk about babies. So the total fertility rate, and this is usually by country because different countries have different situations. Total fertility rate is the average number of children a woman will have in her childbearing years or in her lifetime. If most everybody has 6, then it'll be 6. If some have 6 but some have 4, it might average out to 4 or 5. So it's the average number that a woman will have in her lifetime. Here in the United States, it's actually less than 2 right now. It's like 1.8. It's actually too low. What we would like to see is our populations to all go to a replacement, what we call replacement level fertility. The idea is to replace yourself and your spouse. So every couple has 2 babies, to replace themselves. If that happens, then our population plateaus, which would be a very good thing. In fact, in developed countries like the United States, the replacement level fertility is about 2.1. Actually, I bet in the U.S., because we actually have a really high infant mortality, unfortunately, would be more like 2.2. The 0.2, you don't want to see a 0.2 of a baby, but what that means is out of every 5 couples, if it was 2.2, out of every 5 couples, 1 couple has 3. Or the average out of 10 couples would be that there would be about 21 or 22 babies. The reason for the 0.1 or 0.2 is because not every child survives, unfortunately. Things happen, accidents, tragedies, cancer, sickness, and babies die. Sad thing, but they do. So that's to counteract for that. Unfortunately, that's quite a few children die. So that's what's going to counteract that. So you have to have a few more. In developing countries, of course, their infant mortality is higher. So it's going to be over 2.1. It's probably going to be like 2.6 in a lot of the countries, maybe even up to 3, depending on which country we're talking about. So, but that's what that is. Okay, life expectancy. This is the average number of years of somebody born in a particular country at a particular time. So when all of you guys were born, your estimated life expectancy was over 75, probably around 81 years. Girls, you're a little bit longer. We usually live a little bit longer than males on average. And if, of course, you come from a country with better health care, you're going to live longer. This life expectancy is kind of interesting because it's an average within a cohort. it actually changes over time because unfortunately some of those cohorts, people have passed away. So as you get older, the chances are you will live, your life expectancy actually kind of goes up because the people who have already passed away are already gone and they're not in the cohort anymore. But your life expectancy is around 81 years. So pretty long life. Okay. Infant mortality. This is the number of children who die under the age of 1 for every 1,000 live births. So that's basically accrued infant mortality, if you will. And then we have child mortality. That's how many children die under the age of 5 out of every 1,000 live births. Unfortunately, in the U.S., our infant mortality is actually quite high. Child mortality is not so much, but our infant mortality is. And a lot of that is socioeconomic issues. And that's very common that you have socioeconomic issues. It has to do with poverty and access to medical care and good nutrition and that kind of thing. The fact is, we know if you don't have good nutrition and if you don't have access to medical care, the chances of surviving are very low. Okay, so life expectancy, you can see, actually that's infant mortality, sorry. Looking at infant mortality in the United States, again, it's 6.6 per 1,000 births. That is a lot of babies. It's kind of sad that we're that high. We should be a whole lot lower than that, but we're pretty darn high. It's kind of one of our problems. Okay, moving on. Hope you don't have any questions so far. Let's go through age structure really quick. Age structure are these great pyramids, population pyramids that show you girls on the right, boys on the left. Each band is like the bottom band is from 0 to 5 years. The next one is 5 to 10, 10 to 15, 15 to 20, and so on as you go up. The longer the band is, the more individuals within that band. And as you go up, they usually decrease because, of course, people do die along the way. So a few things these can tell you. These pyramids can tell you a whole lot. And you need to know this. You need to be able to do this. If the pyramid has a very wide bottom, it usually means that the population is growing very fast. The only case where that's not true is if the sides of the pyramid are very, very concave, then your population is probably not. It's probably very stable. Population momentum. This came up actually in class one day, or one of my classes so far this year. Population momentum is the idea that if everybody went to having 2 children, every woman started having 2 and trying to plateau the population, you still have, if you look at that dark green layers, see those really dark bars? They are also the biggest bars, and yet they are the pre-reproductive population. So even as they move up into the reproductive years, even if they only have 2 children each, there's just more of them having children. You're not talking about, you could have 2 million of them, and as they move up, they're going to have 2 million kids. Well, the bars above them were only 1.5 million. So you are going to have this slight population momentum because just the number of kids or individuals moving up into the reproductive years are larger than the number of individuals in the reproductive years. So you're going to have more babies. More babies means population momentum. You're going to continue to grow for a short period of time before your population plateaus. Sorry, taking a sip. Okay, if your pyramid looks like a column or a tower, very kind of straight sides, like the one to the right, this one, that basically is very slow or no growth, probably no growth. If your pyramid tapers in the bottom and kind of looks almost like a diamond, how that tapers, and this is very narrow, then your population is decreasing. Okay. These are the things we can infer from our pyramids. We can also infer that if you have a wide base, you probably have less medical care, less technology, a high infant mortality, because that's why you have lots of kids, because they're going to die. And we'll talk more about that when we talk about population or the demographic transition model. I'm going now because this